Okay, this is the P3 paper from October 2021. It's question number 6, and this is going to be a differentiation question. We're going to be differentiating log functions, we're going to be differentiating trig functions, and we're going to be finding stationary points and gradients. Okay, so let's make a start to that. So we start off just part 1 with y equals log, no it doesn't, sorry, y equals 3 log x squared minus 5 minus 4x squared plus 15. And the first part says, can we show it's got a stationary point? So stationary point means that dy by dx is equal to 0. Need to be aware of the fact that x is going to be greater than root 5. That will get rid of some of our possible answers. So first thing to do is to differentiate. Dy by dx is equal to, how do we differentiate a log? A log is 1 over x squared minus 5. We've got 3 lots of the log, so it's 3. 1 over x squared minus 5 multiplied by the differential of what's in there, and the differential of what's in there is 2x. So that's just a quick version of the chain rule. Minus 8x, and then the 15 just disappears off. Let's tidy that up. That's 6x over x squared minus 5 minus 8x. So that's our dy by dx. And then for stationary points, dy by dx equals 0. So I'm going to get 6x over x squared minus 5 minus 8x is going to be equal to 0. Let's multiply throughout by x squared minus 5. I'm going to get 6x minus 8x. X squared minus 5 is equal to 0. Let's multiply this all out and tidy it up. I'm going to get 6x minus 8x cubed plus 40x equals 0. So I'm going to take everything over to the other side and make it 8x cubed minus 46x is equal to 0. So take x out as a factor, leaves me 8x squared minus 46 is equal to 0, which will leave me x equals 0, or x squared equals 46 over 8 is 23 over 4. So I'm going to get x equals 0, or x equals plus or minus root 23 over 4. If we then go back and remind ourselves that x has to be greater than root 5, we're going to get, let's say that since x has to be greater than, was it 5 or root 5? Greater than root 5, we get x is equal to root 23 over 2. That is the square root of 23 over 4. And what are we looking to do? We were looking to show that it was equal to that. So P here is just going to be equal to 23. So done first part. Okay, let's have a look at the second part. Second part's a completely different question then. So a different curve, y equals 4x minus 12 sine squared x. Show the differential is equal to that, and then see if we can find the maximum gradient. Okay, so that's the answer to that part there. Doing the second part then. So 2, and this is part A first of all. Part A is just, we had y equals 4x minus 12 sine squared x, and they want us to differentiate that. So again, using the chain rule, well that's 4, but using the chain rule for this one, by the time you get to the exam, I'm not doing the chain rule really slowly where we're saying y equals u squared and all of that. You should be past that stage. If you need to do that, go back and have a look at a different video of mine on this channel. But if I'm doing this at the time we were looking at the exam, I treat it as though it's something squared. So that is multiply by the power, take one off the power, which then becomes that. And what you can do, what a lot of people do, if they're a little bit worried about the trig ones, is they think about it as being like that. I've got no problem with you thinking about it like that. So multiply by the power, 24, take one off the power becomes sine, multiplied by the differential of what's in here. The differential of what's in here in this case is just cos x, so I get times by cos x there. So it's the chain rule, really quickly explained. And then what are we trying to do with this? They've said show it's in that format there. So if it's in that format there, we notice sine 2x, so we're going to be using a bit of double angle work here. Really, again, by the time you're doing exams, need to be absolutely on top of this work here. This is 12 lots of 2 sine x cos x. And why have I put it like that? Because 2 sine x cos x is sine 2x. So now I actually have it in the format they wanted. So that value there is 12. Just no excuses, guys, for not learning these bits here. As soon as I see sine x cos x, you should automatically, in your mind, have sine 2x as the way forward with that one. Part B then was just talking about now trying to work out the maximum gradient. So the maximum gradient all depended on what we've got here. This is a nice easy one, and we're using the idea of what are the limits of sine. Well, sine goes from 1 to -1, doesn't it? Now, if we want this actually to be a maximum gradient, let's say that for the maximum gradient, I actually want sine 2x to equal -1, because then I'll be doing minus times a minus makes a plus, and I'll get, sorry, let's just explain that, is when sine 2x equals -1, dy by dx is equal to 4 minus 12 times -1, which gives me 4 plus 12, which gives me 16. This is the maximum possible value I can get for that bit there, is plus 12. It occurs when sine 2x equals -1. Okay, not too bad. A relatively straightforward question for question 6. Hopefully that all makes sense.